Hello everyone, welcome to this course on mechanics of solids. I am Professor Arunasis Chakarborty from the Department of Civil Engineering, IIT Guwahati. This is a basic course for first year students in civil engineering. In this course, we are going to see how the material behaves under the external loading. As you can see on your screen, there are different structures that very often we encounter. In civil engineering, we are familiar with buildings and bridges. There are other structures also you can see on your screen that we deal with in engineering. Now, these structures, they experience external loading, and because of those external loading, these materials also deform. So, in this course, we will study how the material deforms under the external loading, that is manifested in terms of stress and strain. And once we learn how to quantify these stresses and strains, then that forms the basis of any structural design. Because when we design a structure, we first need to quantify the capacity of the structure, and from the external loading we can quantify the demand, and design mostly deal with this capacity and demand. So, in this course we are going to learn the mathematical models of stress, strain and deformation that almost every structures that we deal with, they encounter in their real life. So, this course forms the basic understanding behind any analysis and design that we face in engineering. Now, as you progress in this course, you will see it provides a stepping stone for the advanced applications like finite element analysis, structural dynamics and also advanced material modeling. And hence, this course is essential for all the branches of civil, mechanical, automotive industry, aerospace and other engineering in applied science. So, the topics that we are going to cover in this course is how an elastic material behaves under the action of external loading. It normally undergoes some deformation, and that is manifested in terms of strain. So, we will learn how to quantify this stress and strain due to some external loading. And then from 1D we will expand it to 2D and 3D problems, and we will see how material in 3D deforms and what are the different components of stresses and strains. Then once we learn the models for stresses and strains, study the failure modes that the material always experience before failing. Then we will solve some problems to clear our doubts, and then finally we will also study how to apply energy based method to solve some structural problems. And at the end we will go through the concept of buckling and stability analysis. So, in this course there are three major modules. The first one deals with stress strain analysis. We start with tension and compression in 1D, then gradually we move over to 2D and 3D problems. Then we define plane stress and plane strain problem and some important concepts like principal stress, its direction, Mohr circle and so on. And then in the first module, the last topic will be the different failure theories. Then we will move over to second module, where we will study the response under different types of loading. So, we will talk about bending stress, its distribution across the section of a beam, then shear stress, its distribution. We will define shear center, then Euler-Bernoulli beam theory, how to solve a beam under the action of different types of loading. Then we will study pure torsion, torsional stress distribution and warping, and then finally, the concept of stability in module 2. Then we will move over to the third module, which is on energy formulations. So, we will talk about strain energy, its calculation and its use in solving the structural engineering problem. Then we will move over to principle of virtual work, and finally, we will talk about Castigliano theorems along with some examples. So, these are some of the textbooks that we are going to refer. Apart from that, if any other materials are necessary, that I will provide during the lecture, and after every lecture we will also provide you a series of questions that you are supposed to solve. If you have any doubt, you can also reach us and we can discuss those problems. I hope this course will give you the basic idea of structural behavior and how elastic material deforms, that you are going to use as you progress in your undergraduate curriculum. So, welcome again in this course. With that, let us close here. Thank you very much.